Okay, here are the last 2 pages of the notes. I've lumped these together because there really isn't much to do on page 8. You do have to understand the difference between an angle of elevation and an angle of depression. So both angles are measured from the horizontal. So if you are at one end and you look up, we're talking about an angle of elevation. If you look down, it's an angle of depression. So the thing is that that angle of depression is made with the horizontal, and so it does not always fall inside the triangle. So if you take a look at that very bottom box, when we are talking about the angle of depression from a lighthouse, and we've got that angle of depression right here, it does not do us a whole lot of good outside of the triangle. But think about something. If somebody's standing at the top of the lighthouse, is looking down at a ship, and the angle of depression is 35 degrees, that means that somebody on the ship looking up at the top of the lighthouse has got an angle of elevation that's that exact same measure. So that angle of depression outside of the triangle is going to be the same as the angle of elevation on the other side. That's going to be useful. Page 9. Let's get rid of the red here. Let's go back to the purple. Okay. So example 13. From the top of a lighthouse, 18 meters high. So I'm not going to get super creative drawing my lighthouse. I am going to label it, though, as 18 meters. Okay. The angle of depression to a nearby sailboat is 10 degrees. So here's my sailboat. The angle of depression, again, is always made with horizontal. So this is my 10 degrees. A little more useful if I write it down here and make this angle 10 degrees. Anytime we talk about angle of elevation, angle of depression, we are assuming that we are using a right triangle. That lighthouse is coming straight up out of the ground. Okay. So let's take a look at the information that we are trying to find. We want to figure out how far it is from the top of the lighthouse to the sailboat. So that's the top of the lighthouse to the sailboat. We are looking for this side. It's important that you figure out which piece you're looking for, then go back and reread the problem. Make sure that you are not misreading anything. So we are trying to find the hypotenuse. We have the opposite of the angle. Hypotenuse and opposite, that's the sine. Sine of 10 is 18 meters over x. Multiply both sides by x. Divide by that sine of 10. And we get a distance of 103.66 meters. Because we are talking about a problem in context, we were told that the lighthouse is 18 meters tall. We need to make sure that our answer has got the correct units. Okay, example 14. We are taking a look from the top of a ranger's tower. It's 44 meters away from a tall tree. Couple of things. If this distance right here is 44, then this distance right here is 44. Again, we're assuming that tree is straight up and down. And I don't know what I'm touching on there. 44 meters. Use your imagination. Okay. So we've got this top part y. And then I'm going to call this piece down here x. It's over here. We're just going to move it over to that side because I need both of those pieces to find the height of the tree. So for the top little triangle, that 28-degree angle, I have the opposite side labeled, that's y. I have the adjacent side, that's 44. Opposite and adjacent is tangent. So we've got the tangent of 28 degrees is y over 44. Multiply both sides by 44, and y equals 44 times the tangent of 28. Crank that into the calculator and we get 23.4 meters. And then we're going to find x the same way. Now we've got a 36-degree angle. We've got the tangent of 36 equals the opposite side over the adjacent side, x over 44. So x is 44 times the tangent of 36, which gives us an x that's 31.97. When we add those together, we get a height on the tree that is 55.37 meters. Super tall tree. Okay. Example 15, we're at the very end of these notes. We've got an extension ladder on the top of a 6-foot high hook and ladder truck. The ladder itself is 150 feet. They've labeled it on the bottom. I'm going to label it right there because that's my ladder. Okay. If the angle of elevation of the ladder is 70 degrees, to what height of the building will the ladder reach? And notice here on the side it's labeled. We're trying to find that question mark. And we will go from there. So we're going to use a question mark. Got the tangent of 70. Tangent is opposite over adjacent. So our height is 150 times the tangent of 70. That's the height from the truck. We get 412.12 feet. We're going to make sure we have a correct label. So this part right here is 412.12. We have to add on the 6 feet at the bottom because we want to make sure we are measuring how far up the building we can go. And since our ladder is already starting 6 feet off the ground, we have to take that into consideration. So that ladder will reach 418.12 feet up the side of the building. And that's it. That is 7.2 done.